Okay, let's unpack this. Our mission for this deep dive is to get right into the modern Shopify theme development tooling.
Right. Specifically, the Node.js-based Shopify CLI 3.x.
We really want to give you that shortcut, to setting up a safe and efficient local environment from day one.
And to really get why it's so much safer now, you have to remember the old days, the anxiety.
Oh, I remember it.
If you were on ThemeKit or the old CLI 2.x, it was just a file watcher. You'd hit save, and it would just, boom, destructively overwrite the live files on the server.
I still remember that pit in my stomach just watching the progress bar. You could take down a brand new theme with one bad save.
Exactly. That's the high-stakes game we're leaving behind. The modern CLI 3.x is just fundamentally different.
It doesn't upload to the live theme at all.
No, not when you're developing. It creates a hidden temporary development theme ID. It's basically your own private copy. And it tunnels your local changes through a special preview URL.
A development sandbox. I love that. So before we get to the sandbox, what do people actually need on their machine?
The prerequisites.
The foundation, right?
Okay.
You need Node.js, and definitely stick to the current LTS version. That's long-term support.
So like Node 18 or 20 plus?
Yep, you want that stability. Then Git is, I'd say, non-negotiable for what comes later. And Ruby is good to have around, for any legacy stuff.
And to install, it's that npm install command. A little tip from me, especially for you Mac users out there, use a version manager like NVM. It just saves you so many headaches with permissions versus installing globally.
Good tip. And once it's installed, you can't just start working. You have to tell Shopify who you are.
Right, the authentication step.
You run Shopify auth login. That links your terminal to your partner or your staff account. It establishes that trust.
Okay, so you're logged in. Then you have to link to a specific store, don't you?
You do. That Shopify theme dev store and then your store handle.
Yeah.
That gives the CLI the context for where to, build that sandbox. Which brings us to the golden workflow command, the one you'll use all day.
Shopify theme dev. When you run that, a whole sequence kicks off. It checks you're logged in, syncs your files, uploads them to that temporary ID we talked about.
And then it starts up the proxy server.
Yeah.
Usually on http:127.0.24.9292.
That's the one.
So here's the part that I think is so cool for anyone learning this. It uses that temporary ID, but the preview itself is showing us what exactly.
This is the crucial concept. You're developing using real production data.
So all the live products, the collections, the theme settings.
All of it. But it's rendered with your local code. So the customer sees nothing. It's the best of both worlds. And with hot reloading, you save a file and the preview just instantly refreshes.
Instant feedback with real data. Perfect. Okay, so dev is safe. Where are the landlines? Let's talk danger levels for the other commands.
Shopify theme check. That's green. Low danger is just a linter checking for errors.
Yes.
And you have Shopify theme pull. I'd call that yellow. Medium danger because it downloads from the server and overwrites your local files. You just have to be careful you don't overwrite something you wanted to keep.
And the red flag, the one that keeps people up at night.
Right.
Shopify theme push.
Yes. That's high danger.
Well, what makes it so risky, you're just uploading code, right?
Yeah, because it's not just code. That command ties directly into what I call the settings data.json dilemma.
Oh, okay.
Picture this. You're coding away for a few hours, but in that same window, the merchant logs into the theme editor and changes, the background color, or completely reorders the homepage.
So if I run theme push after they do that, my local outdated version of that settings file just wipes out all of their live changes.
Wipes them out completely. It's a catastrophic data loss from their perspective.
That is an emergency phone call waiting to happen. So what's the safety measure? How do you prevent that?
You always pull their content changes before you start your code changes. The specific targeted command is Shopify theme pull only config settings data.json.
Grab their latest settings first, then start coding.
Exactly. Content first, then code.
That single command is the difference maker. So to recap, we've got the safety of the CLI 301X sandbox, but also this very real risk when you push or pull certain files.
Right. And if we zoom out a little, this all leads to a much bigger question. Given how dangerous Shopify theme push can be, the real question for an architect isn't just about code anymore.
It's about process.
It's about process. How quickly do you need to integrate a robust Git strategy to manage that risk, to stop someone from accidentally overwriting live merchant data? The next step isn't just coding. It's actively protecting that live environment, something for you to mull on.
Welcome back to the deep dive. So today we're jumping into a really interesting one. We're looking at how advanced dev teams handle Git and deployment specifically within the Shopify world.
Mm-hmm.
And the big challenge here, it isn't just about, writing good code. It's about this messy overlap between developer code and live merchant content.
Exactly. That tension is really, it's what we call the core conflict.
Core conflict, okay.
Yeah, I mean, think about it. Normally, you have code in files, content in a database, super clean separation.
Right, the classic model.
But Shopify just kind of breaks that rule, and it really all comes down to one specific file, config settings data.json.
Ah, yes, that file. So if a developer just blindly pushes their version of it?
You've got it. They risk instantly wiping out a merchant's latest live edits, a banner change, a new promotion, gone.
But if they ignore it, then any new sections they've built won't have their default settings, and, well, they'll just be broken on the live site.
Precisely. It's a real catch-22.
Yeah.
So to manage this, most mature teams use a modified Git flow strategy.
Okay, so let's talk branches.
Yep, you got 3 core branches. First is main, or sometimes master. That's mapped directly to the production theme.
And that's done through the Shopify GitHub integration, right? So it's all automated.
Exactly. And the golden rule is it's updated only through pull requests. No direct pushes.
A gatekeeper. I like it. What's next?
Then you have staging, which is usually mapped to a permanent staging theme. That's where you test how different features work together before they go live.
And then the developer's own.
Your feature branch, yeah.
Yeah.
Something like Feat New Banner that's just for you on your local machine using the Shopify CLI.
So let's walk through what you've called the golden workflow. What's step 1?
Step 1 always is to start with a clean slate. You run git pull origin main.
Get the latest production code.
Yes, but here's the pro tip. If you think the merchant might have been making changes live, you should also run Shopify theme pull live.
Ah, so you're pulling their content changes down before you even start working.
You have to. It prevents so many headaches. So you do your work, open your PR, and now we're at the most critical step. Step 4.
The content reconciliation checkpoint.
That's the one. Before you commit, you have to look at that settingsdata.json file and make a call.
Wait, you're telling me this critical step relies entirely on a human remembering to check a file every single time? There's no automated way to do this.
That's the heart of the risk, really. Because the platform mixes data types, it demands human judgment. You have 2 scenarios.
Okay.
Scenario A is a structural change. Let's say you added a whole new theme section.
Right.
In that case, you must commit settingsdata.json. The site needs that new schema to exist.
And scenario B.
That's just a visual tweak. You change some CSS, maybe a bit of liquid. In that case, you should actively discard your local changes to that file.
To preserve the merchant's content.
Exactly. And the best practice here, it's non-negotiable, is to always run git diff config settings data.json before you commit. You have to know what you're pushing.
Absolutely. So let's talk about another gatekeeper, .jitignore. What are we keeping out?
Well, the obvious stuff. API keys in a .enmv file, the CLI cache in Shopify, no modules.
But what about something like templates.json? That feels like another gray area.
It is, and it's a controversial one. Those files define the layout of a page, which sections are where. So they are absolutely code and they must be committed.
Well, what's the risk there?
The risk is a race condition. The merchant goes onto the live theme and adds a new featured products section to their homepage. Meanwhile, the developer, who started their work yesterday, pushes their old index.json file.
And the merchant's new section just vanishes.
It's gone. Wiped out.
Wow. That's a huge data integrity risk. The fix there has to be communication, right?
It's either strict communication like a code freeze or, again, being incredibly disciplined about running Shopify theme pull right before you commit.
So really the big takeaway here is that you're not just a developer, you're also a data manager. Effective deployment isn't just about the code, it's about navigating this blur between code and content.
That's it, perfectly. And if we zoom out for a second, Shopify does try to help. It has a lock file mechanism that warns a merchant if a developer is also editing the theme.
It's technical guardrail.
Right.
Yeah.
But even the sources we looked at say it's not foolproof. So here's the final thought I'd leave you with. If even the platform's own automated safeguard can't fully prevent this kind of data loss, what does that really tell you about the fundamental mandatory role of human communication in any advanced workflow? Welcome to the deep dive. Today, we're jumping right into a really core concept in e-commerce architecture.
A huge one.
Yeah, the monumental shift from those old, restrictive liquid templates to the world of JSON templates in Online Store 2.0.
Right.
If you've ever had to work on a legacy theme, a vintage theme, you know the pain.
Oh, yeah.
Your templates like product.liquid, they just had all the HTML and code right there inside them.
Which sounds simple, but it was incredibly rigid.
Exactly. So if you wanted, say, a testimonial section on a product page, yeah, you just couldn't. Not a dynamic one. It had to be hard-coded, and it was completely immobile.
And that's really the mission for this deep dive.
Yeah.
We want to understand how moving to JSON templates it solved all of that.
Yeah.
It enabled what we now call sections everywhere and completely changed the game for merchants.
Okay, let's unpack this. The biggest shift is that OS 2.0 templates are now JSON files. But wait, if there's no code in the template, how does Shopify even know what to show on the page?
That is the key insight, and it's a little mind-bending at first. The new template file contains literally zero code.
Zero.
It's purely a configuration map. Think of it as just a list of instructions telling Shopify which sections to load and, crucially, in what order.
So it's a map. Okay, that makes sense. So let's look at the anatomy of that map, like a templates product.json file. How is that structured?
It's actually pretty simple. You'll see a main object called sections. Inside, you give each section an arbitrary ID, like main or recommendations. But the important part is the type property, a type of, say, main product. Tell Shopify to go look for a file named mainproduct.liquid inside your sections folder.
So that's the connection. The JSON is the what, and the .liquid file in the sections folder is still the how.
Precisely.
Yeah.
The code still exists. It's just been decoupled from the template itself.
And what about the part that makes the drag-and-drop editor work?
That would be the order array. It is the single most important part of the whole file. It's just an array of those IDs we mentioned.
Like main recommendations.
Exactly. And that array dictates the exact rendering sequence.
Right.
So when a merchant drags a newsletter section above their recommendations, all Shopify does is just rewrite that order array in the JSON file.
Yeah.
It's a real-time control panel, not a static piece of code anymore.
Okay, that clicks. So for anyone listening who's actually migrating an old theme, what's the shortcut? How do you do this refactor?
It's a surprisingly clean three-step process. Let's imagine you have an old templates page.contact.liquid.
Right.
Step 1. Extract the logic. You literally cut all the HTML and liquid code out of that file.
Select all, cut.
Yep. Step 2, create a new section. You paste all that code you just cut into a new file, maybe call it sections main-page.contact.liquid.
Got it. And the last step.
Step 3, create the JSON template. You delete the now-empty page.contact.liquid file and create page.contact.json in its place. Inside, you just list your new section type under sections and reference it in the order array.
And the payoff is that the page looks identical to the user. But now the merchant can go into the theme editor and add, I don't know, a maps section or an FAQ block right above or below that contact form, something that was absolutely impossible before.
It's true freedom. And if we zoom out a bit, this pattern gets even more powerful with something called template suffixes.
Okay, what's that?
Well, you could create a file like product.preorder.json. It could use a completely different set of sections, or maybe the same sections, but with different default settings, all for specific products that you assign this template to.
That brings up a critical point I saw in the sources about the layout property. It sounds a bit technical, but why is that so important?
Oh, that's a classic gotcha for developers. The JSON template lets you specify which global layout file to use.
So you could have a page with no header or footer?
Exactly. You could set layout landing to use a superclone layout file you've made, perfect for conversion pages. But if you forget to set it, it just defaults back to your main theme.liquid.
And suddenly your clean landing page has your site's main navigation and footer all over it. Right.
It's a small detail with big consequences.
So to wrap this up, here's the final thought we want to leave you with. Considering all this power is now centralized in that one simple order array, how does this new architecture fundamentally change how third-party apps have to think about integrating their features into your themes? That's it for this deep dive.
All right, welcome to the deep dive, where we tear through all the advanced documentation so you don't have to. Today, we're jumping straight into advanced liquid logic and, performance engineering. Our mission is pretty simple, really. Find the absolute fastest shortcuts to speed up server-rendered code.
Right. Because if your liquid code takes, say, 500 milliseconds to figure out a data set,
That's half a second.
it's half a second, the user's just staring at a white screen, and that delay, I mean, it doesn't just annoy people, it actively costs you conversions.
Okay, so let's get right to it. What's the number one rule?
The golden rule. Always, and I mean always, reduce your for loops. The single greatest danger we see developers fall into is what we call the nested loop trap.
The nested loop trap. That sounds bad.
It is. It's what escalates the complexity exponentially.
Yeah.
The classic ON problem.
Which is just the technical way of saying your site is about to crash.
Right. Exactly. I mean, think about it. If you're running a loop through 50 collections, and then inside that you loop through 50 products.
You're at 2,500 operations.
Yeah.
Right there for one part of the page.
And you will hit memory limits or just timeout. So we need a better way. A way to process that data that doesn't involve manually iterating over everything in Liquid.
Okay, so if we kill the loops, we still need to process the data. What's the lightning-fast alternative we found in these sources? Is there some magic filter we should be using?
There is, and they're really the unsung heroes of performance here, the native C backend array filters.
C backend. Okay, so we're talking about shifting the heavy lifting.
Precisely. We move it away from the slow liquid Ruby interpreter and push it onto really optimized C++ code that runs on the server.
Let's unpack that. Which of these filters are the heavy hitters? The ones we need to know.
Primarily, you're looking at the where and map filters. The where filter is just phenomenal for selecting objects based on an exact property match.
An exact match.
Yeah, think finding all products where the tag is precisely new. Because it runs on that C++ backend, it's incredibly fast for that kind of check. But, and this is a key distinction, it will fail if you try to do complex contains logic. It's built for speed and exactness.
Makes sense. Prioritize speed over complexity. So what about map? Where does that come in?
Map is all about slimming down your data. So imagine you just need a simple list of every available color on a product.
Yeah.
Instead of a big loop, you just apply map to extract just the option 1 property from all the variants. Then you can pipe that to unique.
And the output is just a simple, clean array.
A simple flat array, like red, blue, green. It's trivial for the server to handle.
That distinction is so critical. The optimized C++ backend versus the slow liquid interpreter. You could write a loop that gives you the exact same output as a where filter, but in performance terms.
You're comparing a race car to a scooter.
Right. It fundamentally changes how we should approach manipulating data.
And if we connect this to, overall code health, there's another architectural shift we have to talk about. You must stop using include.
Whoa, stop using it entirely. Why the hard ban on include?
Because it's legacy. Include causes what's called variable pollution across your entire page. It makes debugging an absolute nightmare. The modern solution is render. Render is faster because Shopify actually optimizes its variable context. When you write render snippet product %, that snippet is totally encapsulated. It only knows about the variables you explicitly pass to it.
Which improves performance and I'm guessing stops those weird unintended side effects.
Exactly.
Okay, here's where it gets really interesting for me. Connecting all this performance talk to modern data structures, like meta objects. So if we're using meta objects to create, say, a custom designer profile that we link to a product, what's the one tiny detail that you absolutely cannot forget?
It's so simple, but it's critical. You have to append .value.
.value, why is that so important?
Well, because internally, a meta field is just stored as a JSON string. It's basically just a big blob of text.
So it's not actually an object yet.
Not until you tell it to be. To force Liquid to actually, parse that string into usable object data, to get the designer's real name or their bio, you must append .value to the end of that meta field call.
And if you skip it?
You're just working with raw, unprocessed text.
Right.
Useless. So, at the end of the day, what does this all mean for you? The clearest path to performance is shifting your logic. Move it away from those slow, interpreted liquid loops and move it toward these optimized native C backend filters. And of course, encapsulated rendering with render.
That's the big takeaway. And to leave you with one final thought on clean logic, Liquid doesn't have a native switch statement like other languages, right?
No, it doesn't.
But using the %case % block is so much cleaner and faster than chaining a long, winding list of C%, %, statements.
Absolutely. It's a huge readability win.
So if you have old conditional logic on your site that handles different product types, like gift card or subscription, go refactor it. Use the case block instead. It's probably the cleanest win for speed and readability you can find today. Go forth and optimize. Our mission for this deep dive is to shortcut you past all those manual data entry headaches.
Right.
We want to introduce you to proper relational architecture in e-commerce using meta fields and, the more advanced concept of meta objects.
The goal is really maximum efficiency, minimum repetition.
Exactly. So think about this scenario. Imagine you manage a massive inventory, maybe 500 products.
Okay.
And every single one says made with 100% cotton. Then suddenly compliance changes, and it needs to say sustainably sourced cotton.
Oh, that's a night.
If you have to manually edit 500 records just for one phrase, you're feeling the pain of what we call flat data.
Yeah, that's precisely the limitation of just using standard simple meta fields. They force you to duplicate that information on every single product.
And it's not just time-consuming.
No, not at all. The risk of typos, of inconsistencies, it just skyrockets.
So what's the solution?
Well, meta objects, they offer a fundamental shift toward what's called normalization. You're basically defining a new independent entity.
An entity.
Yeah, for anyone who knows SQL, it's like creating a foreign key relationship right there on the platform.
Okay, so let's make that practical. I run a high-end furniture store. I've got dozens of chairs from famous designers. I shouldn't have to type the same bio into every single chair's record.
And you don't have to. With meta objects, you create one central designer definition.
A single source of truth.
Exactly. This definition holds all the rich global data, the name, a detailed bio with rich text, their photo, a website link, all of it.
And the products.
The product records just use a reference meta field. It simply links to one of those designer entities.
So that's the magic, right? The merchant sees a clean select designer picker instead of a text box.
Yes, and the real win is if that designer's bio gets updated in that one central place.
It updates instantly across every single product linked to them.
That is efficiency. And crucially, these aren't just back-end tools.
What do you mean?
Meta objects are full platform citizens. You can enable them as web pages, which means they automatically get a unique URL.
That's huge for SEO.
Yeah.
So you get URLs like yourstore.com/designers Raheem's generated automatically.
You got it. You build one generic template, and the platform renders a unique page for every single designer. It really simplifies content generation.
Amazing. Okay, let's dive into a more technically complex use case for our listener. The ingredient system for, say, a skincare brand.
Right. So if a brand uses vitamin C in 20 different creams, we start by defining an ingredient meta object.
With fields for?
Things like the scientific description, maybe a benefits list, an image of the molecule.
Now, the architecture here is key because a product has many ingredients, not just one.
It is.
So when we define the product meta field that links to the ingredient, there's that list of values, checkbox. Why is that specific box so important?
Because that box is what tells the database you're creating a true one-to-many relationship.
Ah, okay.
You're telling the system this one product can reference multiple ingredient entities. If you forget that, it's useless. The product can only link to one.
And the user experience from that.
It's excellent. A customer can click on vitamin C on a product page, get taken to a dedicated page explaining it, and that page can then show every other product that also contains vitamin C.
Okay, a quick pro tip then. Meta objects versus tags. What's the difference?
Good question. Tags are, messy and unstructured. They're great for simple filtering like summer sale.
Just temporary flags.
Right. But meta objects are strictly typed, structured data. They support rich media. If your data needs a description, an image, or its own page, it has to be a meta object.
It's about content versus simple filtering.
Exactly. And connecting this to the bigger picture, this relational power isn't just about products. Meta objects can link across the whole ecosystem to collections, orders, even customers.
Wait, to customers? How?
You could have a skin type profile meta object or maybe an allergy note and link that directly to a customer record. This ability to structure and link data just fundamentally changes how you can use it.
So what does this all mean for you, the listener? Let's take that ingredient example. We can track which ingredients are in which products.
Mm-hmm.
So how could you apply that same architecture to link customers to a history of products that contain ingredients that caused issues? You could move from simple product data to, really, an advanced customer safety profile. That's the power of relational thinking.
All right, welcome back to the deep dive. Today, we're really digging into how to access custom data. We're talking about those critical meta fields and meta objects, and specifically the two very different paths to get that data, server-side with Liquid and client-side with the Storefront API.
Exactly. And that choice between Liquid and GraphQL, I mean, it's not just syntax. It's a fundamental split. Is your data pre-rendered when the page loads, or are you fetching it on the fly? Understanding that is, half the battle for performance.
Okay, so let's unpack that. We have to start with Liquid, right? The stuff that lives inside our theme files. Now, anyone who's been doing this for a while knows there's a new rule that has tripped up, well, pretty much everyone. The syntax it changed.
It really did. It's this shift to what they call a metafield drop.
Yeah.
So when you call a metafield now, you don't just get a simple string back, you get a whole object. And to get the actual data, you absolutely must append .value. If you miss that, you get nothing.
Okay, hold on. Why the change? If the old way was simpler, what was actually wrong with just returning the string? What's the point of forcing this new, this metafield drop structure on us?
It solves the challenge of rich data. By wrapping everything in an object, it lets the system handle complex types, things like rich text, or file references, or even meta objects. It keeps it all consistent. But simple things, like a number, still work predictably once you hit that .value. It's really about future-proofing.
That makes sense. And speaking of those complex types, there's a huge quality of life improvement with the metafield tag filter, isn't there?
For sure. That filter is a lifesaver. You use it, and it automatically handles the output. If the data is rich text, you get the right HTML, all your P and strong tags. If it's a file, boom, you get an MEG tag.
That sounds like magic. But are there, any common situations where you'd want to avoid it and just render things manually?
Yeah, you'd probably skip it if you need really custom formatting. Or say you only want to show, the first paragraph of a rich text block. The filter renders everything, so for that kind of precise control, you do it yourself.
Okay, so manual for surgical precision.
Got it.
Now, Liquid also lets you do this powerful data traversal, right? Chaining through references, like from a product to a designer met object and then to that designer's favorite collection.
Right, and that traversal is super efficient because Liquid is generally eager-loaded.
Yeah.
But, and this is a big but, we always warn against going too deep. You go more than, say, 2 or 3 levels, and you really risk hitting memory limits. It's efficient, but there's a hard ceiling.
So Liquid is the fast lane for server-side stuff. But what happens when you need data to load dynamically? Like a quick view modal that pops up without a page refresh? Liquid can't do that.
And that's where we have to shift gears completely. You need the Storefront API, you need GraphQL. Yeah. And GraphQL is, it's a lot stricter than Liquid. When you query a meta field that references another object, you have to know what type you're expecting.
So you're talking about inline fragments. You can't just ask for a generic reference. You have to explicitly say something like DN on meta object in the query to tell the API, hey, this thing is structured like a meta object.
Exactly. It demands that precision.
Yeah.
You really see that strictness when you get to lists. If you're fetching a list of ingredients and you just ask for the top level value, you often just get a raw JSON string back.
Which you then have to parse manually in JavaScript. That's slow and just clunky.
It's terrible. So the efficient way, the recommended pattern, is to use the references connection directly. Use something like references first, pull the nodes, and get the specific fields you need for each item. You skip that whole parsing mess.
Okay, so to wrap this up, it feels like there are 2 very clear paths here. You've got Liquid for fast, server-side display. Just remember .value and use the metafield tag when you can.
And then you have GraphQL for dynamic client-side loading, where you have to be super precise with your types and references.
Right, so the core decision for a developer really boils down to balancing performance against complexity.
Absolutely. And that's the final thought to leave you with. In your own work, how do you weigh that? When do you choose the server-side certainty of Liquid, where the data is just there, against the client-side flexibility that GraphQL offers, even with all its added complexity? Which trade-off actually serves your user best?
Welcome to the deep dive. So if you've ever had that nightmare of building a custom section for a site, and then you have to copy and paste the code just to change, one little piece of data on another page.
Oh, yeah.
You know the pain. Today, we're looking at the UI element that can end that cycle for good. The Connect Dynamic Source button.
It really is a paradigm shift. We're talking about that little icon, the one that looks like a stack of coins or a database. Mm-hmm. And when you click it, you're basically telling the theme editor, okay, forget static text. Go pull this data directly from the store's architecture. The whole mission here is to make your sections completely agnostic.
Agnostic. What do you mean by that?
I mean, they don't care what template they're on. They just know how to grab the right data for whatever context they're in.
Okay, so let's ground that concept. We talk about the bad architect versus the good architect.
Exactly. The bad architect codes a whole custom designer-profile.liquid file just to print a product's designer meta field.
Right. A ton of work for one specific use case.
A ton of work. The good architect just grabs a standard image with a text section and connects all the data points through the UI using that dynamic source button. It's reusable everywhere.
But that flexibility, it depends on something, right? It's not just magic.
No, not at all. It depends entirely on one thing: schema compatibility.
Okay, so what's the biggest schema trap you see people fall into?
It's all about matching the data type. It's like, a square peg in a round hole. If your section setting is defined as type text, you can only connect it to a single line text meta field.
You can't connect, say, a rich text field to that.
It'll just fail. It won't even show up as an option. You'd need a type rich text setting for that. It's the small things too, like connecting a meta field to a button label. The schema for that has to be a simple text type.
Got it. Okay, this brings us to what I think is the real breakthrough here, which is traversing relationships. Before, this was pretty limited.
Oh, totally. You were stuck at the top level. You could pull the product title, sure, but now with meta objects, the dynamic source picker can actually ren deep link. It can follow the chain of references in your data model.
So walk us through that workflow, because this is where that whole zero code promise really starts to feel real.
Okay, so imagine you're in an image with text section. You click the little database icon next to the image setting.
Right.
You'll see a list. You start by selecting product. That's your current source. From there, you select designer, which is a meta object reference field on that product.
Okay, so you're one level deep now.
Exactly. And then from there, you can select headshot, which is the actual image field inside that designer meta object.
Wait, hold on a second. You're saying that whole sequence connecting data that's basically 3 levels deep, you did that all through the visual editor.
Yep.
No liquid code was touched.
Zero code. And the result is immediate. The section shows the designer's face, and if you navigate to a different product that points to a different designer, everything, the image, the text, the links, it all just swaps out instantly.
Wow.
The goal now is to build these zero-code templates, these JSON files, where every single element is just pulling data dynamically from those nested meta objects, all configured through the UI.
That's incredibly powerful. But we know every tool has its limits. Where does the system break down?
There are two main limitations you need to know. First, arrays, or, lists.
Okay.
You can't connect a list of text's metafield to a single heading setting. The UI is built for one-to-one connections, singular data points. If you need to loop through a list of items, you still have to drop into custom liquid.
Right, so liquid isn't going away, it's just being used for more complex logic. What's the second big trip up?
Color settings. This one gets people all the time. Your standard color schema type in a section. It just doesn't support dynamic connections from color metafields yet.
So you can't have a product's data define the color of a section.
Not directly through the color picker, no. The workaround is to use a generic text input for the hex code, and then you have to apply that value using inline CSS in your liquid. It works, but it's not as clean.
So, wrapping this up, what does this all mean for you, the person listening? I think the key takeaway is pretty simple. If you're building custom sections, just use standard input types. That's what enables all this functionality.
Exactly. The developer's role is shifting. It's less about writing content logic and more about defining a solid structure. The plumbing, really.
And this really decouples the structure from the content delivery.
It does, and that leaves us with a really interesting question to think about. If dynamic sources can make a single section layout work for, hundreds of unique data-driven pages, how does that change the relationship and the responsibilities between the developers writing the code and the content managers who are structuring all that data? That's the conversation that dictates where this is all going.
Okay, let's just dive right in.
Yeah.
So if you're out there managing an online business, you absolutely know this pain point. I mean, think about having like a brand with 50 different retail store locations.
Oh, it's a management nightmare.
A total nightmare, right? Trying to manage 50 separate static web pages. It's slow, it's so error-prone.
And that frustration is exactly what we're digging into today. We're talking about a huge strategic shift from thinking about content as documents to thinking of content as data.
Content as data.
Yeah, we're looking at using a meta-object page architecture. It's essentially a way to define a custom reusable model that can just generate endless pages for you.
So we're moving beyond just thinking in terms of pages and products.
Yeah.
A meta object isn't the page itself. It's more like you're creating a custom database table.
Exactly. Let's call it location.
Okay, location. And in that table, you define the fields you need. Store name, address, a photo.
Right. And then you tell the system, hey, for every single row of data in this location table, I want you to automatically build a unique web page.
And that's the core idea. You define the structure once, you design the master template, the layout, just once.
And the platform does the heavy lifting. It handles all the automatic routing, generating unique URLs like locations in New York for every entry you add. It scales your content instantly.
So let's run that 50-store scenario. We define our location meta object with fields like store name, address, maybe store photo,
opening hours, things like that. Then you go into the theme editor and design your layout. You connect, say, an image banner section directly dynamically to that store photo field.
And this is the aha moment, right?
This is it. The merchant just goes into the admin, adds a new Tokyo store, and fills out the form. They hit save, and boom.
The page is just live.
Instantly live, perfectly styled, consistent with all the others, and SEO ready. And they did it all without touching a single line of code or duplicating any work. It gives so much speed back to the team.
Okay, I get it for standardized things like store locations. But what about the total opposite? You know, the really custom stuff. Like, if a marketing team needs a unique landing page for a summer sale that needs to look completely different from the rest of the site, does the system break down then?
That's a great question. And no, actually, this is where it really shines. You just move the complexity from code back to data.
How so?
You just create a new landing page meta object with campaign-specific fields. Things like hero image, a featured collection reference, and, this is the cool part, a flexible field like theme color.
But that sounds a little risky. You're giving the marketing team, who, they don't code, a lot of control.
Right.
What's stopping them from accidentally messing up the single master template that governs every single page?
But that's the key. They can't mess it up.
They can't.
No, because there's a separation of concerns. They are only changing the data, the text, the image, the hex code for color. They never, ever touch the underlying layout or the code.
Got it. So after that initial template is set up by a developer?
The marketing team can spin up 10 different A/B test landing pages just by filling out a form. The dependency on developers for content creation just drops to near zero.
And this power means you can totally redefine some of the more limited structures we're used to. I'm thinking about standard blogs.
Exactly. Why be stuck with just a title and a big block of text?
Right.
Instead, you could define a dedicated recipe meta object. Now you have specific structured fields. Ingredients could be a list of text, instructions as rich text, and even calories as a number.
And when you build the all recipes index page, you can build a custom section that knows to just go look for all recipe content.
Yes, and you can display a beautiful grid showing the recipe title and, critically, that exact calories number right on the card, because it's actual data, not just text buried in a paragraph.
So when you boil it all down, what does this all mean for you listening?
The core value is pretty simple. You define a structure one time, you manage the data easily, and you generate infinite consistent web pages automatically. It's a transformation from static content management to dynamic data management.
Yeah, it's way more than a tech upgrade. It's a strategy upgrade.
Yeah.
So here's a thought to leave you with. If custom meta objects can replace basic site elements like blogs and pages, what existing limitations in your own current content structures could be completely redefined and scaled using this data-first approach? Something to think about. Welcome back to the Deep Dive. So you've sent us a ton of material on Shopify's big shift to GraphQL. Our mission today is to give you the shortcut. We want to understand why the old REST way is now legacy, and more importantly, where the real security risks are hiding. Okay, let's get into it.
Yeah, and the whole reason this shift even happened comes down to one word: efficiency. The core problem with the old REST API was that it forced you into both overfetching and underfetching.
That sounds like it shouldn't even be possible at the same time.
It does, right? But overfetching is when you say you just want a product's price and title, but you get this huge file back. It has SEO data, creation dates, maybe all 50 variants, just a total waste of bandwidth.
Okay, so you're getting way too much.
Exactly. And then underfetching meant if you needed something related, like the name of the product's collection, you had to stop everything and make a whole second API call.
A second full call just for that one little thing.
And that's GraphQL's big promise. You can just ask for exactly what you want. Give me the product title and the price of the first 5 variants. And that's all you get. It's lean. It's fast.
But that speed comes with a huge catch, because Shopify doesn't just have one API, it has 2. And confusing them is, well, the critical security risk.
It really is. The fastest way to compromise a store.
So let's talk about the first one, the one that frankly gives me anxiety just thinking about it.
That would be the admin API. Think of it as server-side. It's basically God mode.
God mode, okay.
It needs a private, secret API key and access token. This means it should only ever run in a secure place, like on your server or in a serverless function. Its powers are, well, huge. It can read and write everything. Unlisted products, customer emails, you name it.
So if that key gets out, say a developer accidentally pushes it to a public GitHub repo, what's the worst case scenario?
The worst case. Total catastrophic loss. A hacker can delete your entire store. They can scrape all your customer data. It's over. So let me be really clear. You must never expose admin API keys in your front-end JavaScript. It is absolutely non-negotiable.
Right, so for anything on the customer-facing side, we need a different, much safer option.
And that's the Storefront API. It was built specifically for that, for client-side use in, headless websites. Its access token is public, so it's safe to have in your code.
And the key difference is what, exactly?
It's all about context. It only sees what a customer should see. So it's mostly read-only for the catalog. You can do things like create a cart or add an item, but that's about it. And crucially, it automatically filters things out. It will never return a draft or archived product, even if you ask for it.
That distinction is so critical. So we know the risk, but to really get why it's so powerful, we have to look at how GraphQL actually sees the data. This is where it gets really interesting. It's not a table or a list. It's a graph.
Yes, a graph of interconnected nodes. And this is where the jargon can trip people up with edges and nodes. Let's just simplify it. A connection is a list of things, like variants. The node is the actual thing you want, the variant object. And the edge is just the link between the parent and the item. It's mostly important for pagination, for moving through big lists.
And once you get that nested idea, you can run what some sources call the impossible REST query. You can fetch all this deeply related data that would take in, 5 or 6 different calls before?
At least. With GraphQL, you can ask for the store name, then the first 3 products. And for each of those products, their first 3 images, and the title of the collection each one belongs to. All of it, in one single request.
One round trip. That's the power.
That's the power. And that's why the admin API, with that power, is so dangerous if it's not secured.
So wrapping this up, the biggest takeaway for you is that security is everything. You have to know which API you're talking to, which one has God mode, and which one is locked down to the customer context.
And to take it one step further, I'll leave you with a final thought on global IDs, or GIDs. Shopify is moving away from simple numbers for IDs. The admin API might still accept old integer IDs sometimes for legacy support, but the Storefront API, it requires these new base64 encoded GIDs. So the question you should be mulling over is this. If the whole system is being built around these unique identifiers, how much of your future work is going to break if you aren't properly managing and storing those GIDs from the very start? Something to think about.
Okay, so let's jump right in. We're doing a deep dive today into making GraphQL queries, faster and more efficient. I think the mission here is really to understand how GraphQL fixes some of these huge data problems that we all had with classic REST APIs.
Exactly. And that whole problem really just boils down to one word: pagination. With REST, you're always stuck with that offset pagination, the classic page 2 in the URL.
Right. And the reason that breaks down, it's not even about how many records you get back, is it?
Yeah.
It's the database query itself. If you ask for, say, page 50, the database literally has to count through all 49 pages before it just to find out where to start. It's a huge performance killer.
It's an absolute nightmare at scale. Yeah. And GraphQL just sidesteps that entire costly process. It uses what's called cursor pagination.
A cursor, so like a bookmark.
A bookmark is the perfect way to think about it. Every single piece of data, what GraphQL calls an edge, it has a totally unique ID. So instead of asking for a page number, you just say, hey, give me the first 10 products after the cursor of the very last product I just saw. It's an immediate jump, no counting involved.
Wait, so the efficiency isn't just about sending less data. It's a completely different database query under the hood. That's a massive change. So how do we actually, manage that, for an infinite scroll feed?
It's actually pretty simple. In your query, you have to ask for 2 specific things: the page info object and the cursor itself for every single edge. Then the logic is, you start with your cursor set to null. You make the request. And then you just check one thing. Is pageinfo.hasNextPage true?
And if it is true, that's our signal to go again. So we just need to grab the pageinfo.endCursor, right? That string becomes our new bookmark for the next request, and we just do that over and over until hasNextPage is false.
Precisely. So, okay, we've solved the speed problem, but GraphQL brings in its own little challenge, which is resource management. When you're using a service like Shopify, they don't just limit you on API calls per second, they use a system of cost points.
Right, and this is super important if you're building an app. You have to think about your budget. You might get, say, 1,000 points to spend, and that budget refills, but really slowly, maybe 50 points a second.
Something like that. And a simple field might cost 1 point. But the real budget killer, the thing that gets everyone, is nesting connections. That's the trap. Imagine you ask for 100 collections. Okay, fine. But then, for each one of those collections, you ask for 100 products.
Oh, wow. So that's 100 times 100. You're looking at a 10,000 point query right there. And if your whole budget is only 1,000 points, you just hit a brick wall.
You're instantly throttled. Yep, the query just fails. But the nice thing is, GraphQL actually tells you why you failed. The JSON response comes back with an extensions object in it, and inside, it'll show you the requested query cost and your throttle status, so it's very transparent.
So knowing we can blow our budget that easily, we have to write smarter, leaner queries. I guess this is where things like fragments come into play.
That's the perfect use case. Yeah, fragments are basically GraphQL's way of doing the DRY principle. Don't repeat yourself. I mean, if you need a product's title, price, and image in 3 different places in your query, you don't write that out 3 times. You just define one reusable chunk, maybe call it product card fields, and then you reference that fragment wherever you need it. It keeps everything so much cleaner.
That makes total sense for repeating the same group of fields. But what if I need the same field twice, just with different arguments? Like I need the meta field for color and also the meta field for size on the same product.
Good question. You can't just write metafield twice. The server wouldn't know what to do. You'd get a collision in the JSON. This is why we have aliases. They let you rename the result on the fly. So you'd write your query as color_data.metafield and then size_data.metafield. Same field, different names in the output, no conflict.
So really, when you boil it all down, optimizing GraphQL is about a few core ideas. First, get the cursor logic right for speed. Second, watch out for those nested connections to stay under your cost budget. And third, use tools like fragments and aliases to keep your code from becoming a mess.
You've got it. That's the whole game right there. And, since an application can actually see its own cost in that extensions object, it poses a really interesting question. What's the best strategy for an app to, dynamically adjust how much data it asks for before it gets throttled? How can it keep that user experience smooth even when the server is under a heavy load? Something for you to chew on for your next project. Welcome back. Today we're doing a deep dive into the tools that are, really defining modern e-commerce speed.
We are.
Specifically, we're looking at Shopify's headless stack. That's Hydrogen version 2, and its hosting platform, Oxygen.
Right. And the mission here is to get past the marketing fluff. We want to really analyze the architecture.
Yeah, how does this combination actually make things so fast and secure compared to, the traditional setups?
And for anyone who knows the old Hydrogen, you really have to hit a reset button.
Oh, really?
Yeah, Hydrogen v2 is a complete rewrite. I mean, it's now built entirely on Remix, using tools like Vite.
Okay, so Remix, that signals a huge shift toward the server, right?
Exactly. It's a server-centric approach, and that's the foundation for all the speed we're going to talk about.
So let's unpack that. The architecture of speed. When I, as a user, go to a site built with this, what's happening to make that first page load feel instant?
The strategy called streaming SSR.
Streaming SSR.
Streaming server-side rendering. And, think of it this way. The server doesn't wait for every little thing to be ready.
It doesn't wait for all the images, the product recommendations.
None of it. It immediately sends the basic HTML, like the skeleton of the page, to your browser.
So I see something right away, no blank screen.
Exactly. Then it streams in the heavy stuff, like those recommendations or personalized prices afterward.
And the hosting layer that makes this possible is Oxygen. Now, this isn't just one server in a data center somewhere.
No, not at all. Oxygen is a worker-based platform. It basically copies your code to hundreds of edge nodes around the world.
Hundreds. So the server is physically closer to the customer, which cuts down on latency?
Massively. And because it's Shopify's own system, it has some built-in advantages. It uses a shared cache that's already optimized for Shopify's APIs.
So it avoids making the same request over and over.
Right. And for developers, it also has native private storefronts.
Yeah.
So you can password protect your staging site right at the edge. Super useful.
Okay, that's the infrastructure. Let's switch to the code itself. You mentioned security. How do you stop sensitive data from being fetched, insecurely in the browser?
This is the biggest change. The old React pattern of using useEffect to fetch data.
Yeah.
It's gone. You just don't use it.
So what's the replacement?
It's called the loader pattern, and it's really the guarantor of security here.
Okay, how does a loader work?
So when you request a page, that request hits the server, an Oxygen Edge node, and the loader function runs securely on the server.
Before the page even renders.
Exactly. It runs your GraphQL query, gets the data from the Storefront API, and then it just passes the clean, safe JSON to your component. The browser never sees your API keys or anything sensitive.
Got it. So the server does the secret handshake, and the component just gets the final data to display. That ties into the file system routing, like products.handle.tsx for a product page.
Precisely. And to make it even easier, Oxygen injects a helper into that loader. It's called context.storefront.
A helper, what does it do?
It's a pre-configured client that just handles a ton of boilerplate for you, automatically.
Like what kind of stuff? Why is that so powerful?
Well, it manages 3 crucial things right away. First, authentication. It just uses the public access token for you.
Simple enough.
Second, localization. It figures out the right currency and language from the URL or the user's headers.
Oh, wow. Okay.
And third, caching. It applies smart default cache rules. All of this happens at the edge before your component even thinks about rendering.
So the takeaway for someone building a store is what? Hydrogen and Oxygen are basically a unified system that forces you to build in a fast, secure, server-first way.
That's it perfectly.
Yeah.
It moves the logic and the data as close to the customer as physically possible.
And that leads us to our final thought for you to chew on.
Yeah, think about this. If all the key operations, authentication, localization, even fetching the main product data, are all handled securely at the edge before the UI even loads.
You already know the user's context instantly.
Instantly and securely. So what kind of new, deeply personalized experiences can you build when those old constraints on speed and context just completely disappear?
Welcome to the deep dive. Today we're digging into how modern headless commerce it completely changes the game on speed.
It really does.
We're looking at middleware and this really radical approach to edge caching to see how we can basically defeat the laws of physics.
Yeah, and you have to, because latency isn't just a number on a screen. It's the enemy of revenue. I mean, think about it.
Right.
Your server is in Virginia. Your customer is trying to check out in Tokyo. That's a 10,000-kilometer round trip for the data.
And every 100 milliseconds of that delay costs you. We're talking millions in abandoned carts. It's huge.
Absolutely. So you've got these amazing platforms like Hydrogen running on, a global host like Oxygen.
And they deploy your code everywhere to over 100 locations. That doesn't solve the core problem, right? The code is closer, but it still has to call that database 10,000 kilometers away.
Exactly. So the real breakthrough, the thing that changes everything, is edge caching.
Sure.
We don't just put the code near Tokyo. We tell the local edge node, the machine right there, to save the final rendered HTML.
The whole page.
The whole page. So the next visitor from Tokyo gets it in, 10 milliseconds? There are 0 database calls. It's just instant.
That kind of speed sounds amazing, but also a little tricky to manage. How do you control all those copies of the page?
It's actually surprisingly simple. It all comes down to the cache control HTTP header. You set it right in your app's loader function.
And you're basically putting 2 different expiration dates on it.
Precisely. You have max age, which is for the user's browser. You keep that super low, like 30 seconds, so prices don't get stale.
Okay, that makes sense.
But then you have smaxage. That's the one for the big shared edge cache. And that one you crank way up, maybe an hour, 3,600 seconds. That's the jackpot.
Which leads to the magic sauce you were talking about, stale while revalidate SWR.
Yes. So imagine that hour-long cache finally expires. A user requests the page. What happens?
I assume it has to go get the new one, so there's a delay.
Nope. The edge node instantly serves the stale page, the one that's an hour old.
Wait, hold on. You're serving old data. Isn't that a risk? Sacrificing accuracy just for a feeling of speed.
That's the brilliant part. The user gets an instant page, load 0 perceived latency, and while they're looking at it, the edge is already rebuilding the fresh page in the background.
Ah, I see. So that new page is ready for the next person who visits.
Exactly. It's a guaranteed instant hit for every single user, no matter what the cache status is.
And developers don't have to write these complex headers by hand. I saw in the source material, frameworks like Hydrogen have these simple utility helpers.
Yeah, you just call a function. Long cache, done. But this all connects to the real gatekeepers of the whole system, middleware.
Okay, but why add another step? If speed is everything, isn't middleware just more processing time?
It's a critical pre-processing step. You can't do modern commerce without it, especially with internationalization.
Right, markets.
Think about a URL like rvcat product shirt. Before anything else happens, middleware has to intercept that request.
In that server.ts file?
In that file. It detects French-Canadian, and it tells the API context to fetch everything in French and in Canadian dollars before the query even runs.
And if you don't do that, your cache becomes a nightmare. A U.S. visitor caches the English page.
And the next visitor is from France, hits that same edge node, and gets English and U.S. dollars.
A complete localization disaster.
Total disaster. So if you don't vary the cache by that context, the whole system just falls apart. The middleware adds a header, something like vary Shopify store context, to make sure that never happens.
So really, what this all means is you have smart edge caching, which is then made context-aware by the middleware.
And that translates directly to guaranteed sub-50 millisecond speed. You're not just moving the code closer to the customer, you're moving the entire server.
So for everyone listening, what's the final takeaway?
It's verification. The real challenge for you is to go try this. Deploy your code, open your network tools, and look at the headers. The very first load has to say Xcache. Miss. Refresh the page. That second load must say Xcache. Hit. That's when you know. That's the proof that you're beating latency and delivering an instant experience.
All right, welcome back to the deep dive. Today, we are strapping in for a pretty high-speed tour of e-commerce architecture.
A really big one.
Yeah, we're focusing on this monumental shift happening at Shopify. We're talking about the end of checkout.liquid and the full move to checkout extensibility.
And this is so much more than just some minor technical update. This is a complete architectural separation. For years, being able to customize the checkout with raw code, it created this massive systemic risk.
A risk they had to address.
Exactly. This change fixes critical foundational problems in security and stability that really they just couldn't ignore anymore.
Okay, let's unpack this. Our mission here is to quickly get to the bottom of why the old system was so dangerous and what this new sandboxed reality really means for developers. So if you've been in this world for a while, you know the freedom of checkout.liquid made the checkout feel a bit like the Wild West.
Oh, absolutely.
You could edit raw HTML, add Google Tag Manager, custom banners, even use some, hacky JavaScript to hide shipping methods.
It was great for quick customizations, but the cost was huge. The source material is quite blunt about it. The cost was security. The single biggest threat was skimming attacks.
And what are those exactly?
That's where malicious JavaScript literally steals customer credit card details right as they're being typed in.
Yeah.
And that vulnerability was just inherent to the old architecture.
But hold on, if it was such a huge security nightmare, why did Shopify let that architecture exist for so many years? That seems like a massive risk.
Well, it wasn't just tolerated, it was almost a necessary evil for customization. Until the platform got to a scale where stability had to be number one.
Okay.
Every single piece of custom code made the checkout brittle. And that brittle code was actively preventing Shopify from rolling out major improvements, like their new one-page checkout.
So the custom code was basically holding platform innovation hostage.
Exactly.
Yeah.
So that, combined with the extreme security risk, it just demanded a total reboot.
And the deadline is final. Checkout.liquid is gone. Plus, merchants have to migrate. So we've moved from, editing code to installing extensions?
That's it. And the fix is all about isolation. What's fascinating here is the core shift. These new extensions don't run on the checkout page itself. They run in a separate web worker.
A secure environment, the sandbox.
The sandbox, exactly.
And the real genius of the sandbox is what it doesn't let you do, right?
That's the whole point.
Mm-hmm.
The code running inside your extension is fundamentally banned from accessing the document object model, the DOM.
So you can't just run document.querySelector to grab data.
It's blocked. And even if your extension code is buggy and crashes entirely, the checkout itself stays up. It remains operational. Your extension just vanishes without taking the purchase down with it.
Which is why the new development rules are so strict. Because you're in that sandbox, you can't just create raw HTML anymore. No more custom divs or MG tags.
You're forced to use Shopify's own UI library components, things like banner or text.
And here's where it gets really interesting for developers, I think.
Mm-hmm. By forcing everyone to use these specific components, Shopify can take that code and render it natively, automatically, whether the customer is on the web, an iOS app, or Android.
Right. The developer writes it once. Shopify makes it work everywhere. And you don't just drop this code in randomly either.
No, you have to attach it to specific targets.
Extension points, yep. So for a generic block, you might target purchase.checkout.block.render. Or for something really specific, like right after the shipping options, you'd use purchase.checkout.shipping-option-list.render-after.
And it's all defined structurally in that configuration file, the shopify.extension.toml, which is like the rule book for where your code is allowed to go.
Yeah. If we connect this to the bigger picture, this whole shift is just a profound commitment to long-term platform health. They're trading that wild west of developer freedom
Right.
for guaranteed guardrails, for a stable, predictable, and protected user experience.
So what does this all mean for someone listening? The development constraints are, they're definitely tighter now.
They are, but the payoff is massive. When Shopify makes a huge change like moving from a 3-page to a 1-page checkout, your extension just adapts. It works perfectly because it was built with their native components, not with some hacky HTML. It's future-proof.
By design.
But I guess the real question for developers is this. Will this level of forced uniformity and control eventually stifle the kind of groundbreaking custom checkouts that really defined the Plus platform in the first place? Something to think about. All right, let's pull out the architecture blueprints today. We're doing a deep dive into Shopify.
Yep.
Specifically, how you, the developer, can build delivery customization functions. So you're modifying the checkout experience on the fly.
And the very first thing you have to understand, the critical architectural constraint, is that these functions don't run on some external server.
Okay.
They run inside Shopify's core execution path. And that means latency is, it's lethal.
Lethal in the checkout flow. You can't have that.
Exactly. So to keep that checkout feeling instant, you've got this brutal speed limit. We're talking sub 5 milliseconds.
Wow.
To pull that off, Shopify uses a really streamlined structure. Think of it this way. Input, logic, then output.
Okay, input, logic, output. That's the shortcut.
It is. And that logic in the middle runs in WebAssembly, or WASM. So it's high-speed, compiled, sandbox code. Very, very fast.
That immediately makes me think about constraints, especially on data. So let's unpack that input. What data do we actually get?
So Shopify sends your function a JSON object. It has cart data, shipping methods, all the stuff you'd expect. But here's the limitation, and it's a big one. You can only access the data you predefine using a GraphQL query. It's in a file called input.graphql.
So you can't just query the database whenever you want.
Not at all. You're working in a high-security vault. You have to tell them what you need before you go in, and that's all you get.
That forces you to be incredibly precise. Okay, so let's run a scenario with that data. Say a merchant wants to hide their express shipping if the cart subtotal is under $50.
Okay. So first, you need to make sure your GraphQL query actually asks for the cart's subtotal amount.
Right. If you don't ask for it, you can't see it.
Then, your WASM logic just checks if that subtotal is below 50. But this is where that speed constraint gets really real.
You mean the 5 milliseconds?
Yeah. If your logic takes, say, 6 milliseconds, the function just times out, it fails, and the checkout just shows the default delivery option.
Oh, so it's not a soft failure. The user just gets a standard checkout.
You failed the user, yeah. The stakes are high.
Okay, so the output mechanism must be just as locked down, right? It's not just returning a simple true or false.
No, not at all. You return an array of specific operations. You don't just give general instructions. You can only do one of 3 things: hide, rename, or move.
So in our $49 cart scenario, the output isn't a string that says hide express shipping.
No, it's a JSON array.
Huh.
And inside is a hide operation targeted very specifically at any delivery option whose title includes the word express. It's surgical.
Got it. Okay, let's try a rename example then. What if you want to change standard shipping to something like local NY courier, but only for customers in New York?
Great example. The first thing you have to do is go back to your input.graphql file.
And add the customer's address.
Specifically, the delivery address.province code. Without fetching NY, your logic has nothing to check.
And if that check passes, the output is just that specialized rename operation.
Exactly. Customizing the experience just for those New York customers and no one else.
Okay, so there's one final crucial hurdle, right?
Yes. And this is the thing that trips up so many people. After you deploy your function, even if the logic is perfect, it's still dormant.
It's not active.
Functions are installed, but they are not active by default. You have to take a separate administrative step using the GraphQL admin API.
What's up?
You have to run the delivery customization create mutation. That's what links your function's ID to the store and actually turns the rules on.
So until you run that mutation, all your clever code is just sitting on a shelf doing nothing.
Absolutely nothing.
So what this framework gives us is this hyper-performant but very constrained environment. It lets developers enforce these really granular business rules like hiding or renaming instantly right in the checkout.
Precisely. And this really forces a developer to approach e-commerce logic in a totally different way. So my final thought for you is this. Given that performance is completely non-negotiable, that sub 5 millisecond requirement is a hard wall, how does this architecture fundamentally change how you design and validate logic compared to the old way of just calling a slower external API? It demands a kind of precision we almost never see in web development.
Welcome to the deep dive. Today we're tackling a really crucial problem. How does an online merchant actually enforce a sales rule?
Right.
We're not talking about just nagging a user. We mean delivering the absolute power of NO. And we're going to do that by diving into Shopify's validation functions.
Yeah, and you got to understand the legacy pain point here.
Yeah.
I mean, for years, every rule like limit 2 per customer was all done with client-side code.
So cart.js or something in the theme.
Exactly. And the critical flaw was always the same. If a user was savvy enough to disable JavaScript or even just use a direct checkout URL,
those rules just evaporated.
we were gone. The merchant was basically just relying on trust, not real enforcement.
So this fix is a completely different way of thinking. Validation functions run deep, at the API level.
Mm-hmm.
This means if the function flags an error, the checkout just stops. It's a physical block way before it even thinks about hitting a payment gateway.
And what's fascinating is the scope here, because it's dual. It runs the cart level, so you get that immediate feedback for the customer.
Okay, so they know they need to fix something right away.
Right. But then it runs again at checkout, kind of as the final non-negotiable security check. Now, if this is all happening at the API level, I have to ask, what about latency? How does Shopify keep the user experience snappy?
That's a very valid concern. And the answer is really optimization. So the first step, this input.graphql query, it acts like a super strict data contract.
Ah, so you only ask for what you absolutely need.
Exactly. For our limited edition example, we might only query for the line item quantity and maybe check if a product has a specific tag, like limited. The request payload is kept incredibly light.
Right, to minimize that runtime.
Yeah.
And that data then feeds into the logic file, your srcrun.ts.
This is where the magic happens.
Yeah, this is the execution environment, is where the actual business rules live, and it operates fast, often using WebAssembly for speed. So following your example, the code would just loop through the items, add up the quantity of the limited products.
And if it goes over the limit, say 2?
It creates and returns a very specific, detailed blocking error object.
Okay, so the code figures out there's a problem. But the next challenge is telling the user where the problem is, right? You don't want just some generic banner.
Precisely. And that's where the power of the target field comes in. It's huge for user clarity. You don't just target the cart.
Yeah.
If the issue is one specific product, you can target the exact line .ad, and the error message appears right under that item. Or if it's a shipping thing, you can target the delivery group section itself.
That's critical for conversion. Users know exactly what to change, and that clarity really shines in more complex scenarios, like the no PO box delivery for heavy items rule.
Oh yeah, that one requires a few different checks.
It does.
You need to fetch the whole delivery address, specifically the address 1 line, but at the same time, you're also checking for that heavy product tag.
Yeah.
The complexity is running a pretty sophisticated regex check on that address.
Like PO box I.
Right, and the reason you need that kind of regex is because customers don't standardize. Some type PO box, others use PO box with the periods.
And you need to catch all of it, capitalization or not, to make the rules stick. And then that error gets targeted right back at the address field, forcing them to fix it.
If we connect this all back to the user experience, it's it's definitive. There's no confusion. When that validation fails at checkout, the Pay Now button actually shakes.
Oh, wow.
Yeah, and your custom localized message appears in bright red, and that transaction is physically blocked before it ever touches the payment processor. For you, the merchant, this is absolute control.
So this means merchants gain true API-level security over their transactions. All those old loopholes are just gone.
They're gone. And since we've now secured the core transaction rules with this powerful power of NO, the logical next question is, what happens after validation passes? What if you want to change how payment options themselves are displayed?
Like renaming them or reordering them based on what's in the cart?
Exactly. And that leads us straight into our next deep dive, the world of payment customizations. Welcome to the deep dive. Today we're going to get into something with some real surgical precision for the e-commerce checkout.
Yeah, this is some powerful stuff.
We are talking about dynamically customizing payment options.
Yeah.
So renaming them, reordering them, all based on real-time factors. And our mission today is really to unpack the engineering that lets you create that, perfectly tailored payment flow for every single customer.
Right, and the engine that powers all this, it sounds complex, but it's really not. It's actually incredibly powerful because it's so simple.
Yep.
You should think of it as a strict pattern. You have an input, some logic, and then an output.
Input, logic, output. Got it.
Exactly. And the input is just all that real-time context. So what's the cart total? Does the customer have any specific tags? What payment methods are even available? The logic just takes all that and decides what to do.
Okay, so let's jump into the practical side of this. The
Yeah.
why.
Yeah, the why is what matters.
First thing that comes to my mind is just risk management. That seems crucial.
Absolutely. That's
Yeah.
a huge one.
I mean, if you're selling high-ticket items, you might want to get rid of options that, leave you a bit exposed.
For sure. So a classic example is using the cart total as a trigger. Let's say anything over $1,000.
Okay, $1,000.
That becomes a trigger to just hide cash on delivery. SEO just disappears as an option.
Right, so you don't risk a no-show on a really big order.
And that same idea extends right into targeting and exclusivity.
So like for B2B customers.
Exactly. If you have a B2B operation, you only want to show something like a net 30 invoice to customers who are actually tagged as a B2B account.
Makes sense. But for me, the most interesting one is steering behavior,
Right.
for cost savings.
Oh, yeah. The gentle nudge.
Yeah. So instead of hiding a method, you just sort of push the customer towards a cheaper one for you.
Like if a bank transfer saves you, say, 2% in fees.
You just rename it to a bank transfer, save 2%. A little psychological nudge.
That's it. So to do all this, the logic really has 3 core actions it can perform. It's hide, rename, and move.
Hide, rename, move.
Okay. Hide handles the risk, like we just talked about. Rename handles all that messaging and nudging. But move. Move is where you get to take direct control of the visual hierarchy.
And when you say move, you can get really specific, right? You can move a preferred method, like a credit card option, to index 0. Why is that number so important?
Because index 0 guarantees it is the very first option the customer sees.
Always at the top.
Always. It cuts through any default sorting. It's so critical for A/B testing or just making sure your preferred method is always, above the fold.
So let's connect the dots. How do these 3 things combine? The source material had this great advanced example. The VIP wire transfer.
Oh, yeah. That one's a perfect illustration of how this all comes together.
So break it down for us.
Okay, so the goal is to take a standard method. Let's just call it bank deposit, right?
Simple enough.
And you want to rename it to something that sounds a lot more premium, like VIP wire transfer, priority processing.
Ooh, I like that.
But, and this is the crucial part, that rename only fires if the buyer's detected as having the VIP customer tag.
I see. So you're tying my customer identity directly to the presentation at checkout.
Exactly. It's all about creating that premium experience for your best customers.
That VIP example is brilliant, but it feels like it depends on hard-coded rules, doesn't it? Like that specific VIP tag or the $1,000 threshold.
Mm-hmm.
What happens when a merchant needs to scale? They've got 20 different customer tiers. Are they stuck calling a developer every single time the business strategy changes?
That is the key question. And the answer is absolutely not. That's where the architecture gets really reusable.
Oh.
It's through something called function configuration metafields.
Okay, what are those?
So instead of a developer hard-coding VIP into the logic, they just store that value, the target tag, in a customizable field, right there in the store's admin settings.
Yeah. So you're moving the control out of the code and into the admin panel.
Precisely. That's the pivot. The logic just pulls the criteria from that setting when it runs. So the merchant can change the tag from VIP to wholesale or update the risk threshold, and the checkout updates instantly.
The business team is in control, not the dev team.
That's the whole point.
And that just brings it all home. This isn't just about hiding a payment option here or there.
Not at all. It's much bigger.
It's about truly optimizing the entire conversion funnel. You're combining that real-time context with these flexible operations, hide, rename, move, and you're building these completely friction-free flows.
All designed to maximize conversions, maximize order value. So since that business logic is now a dynamic thing that the merchant controls.
Right, through those admin metafields.
The final provocative thought for you to explore is this. Given that flexibility, how many different dynamic checkouts could you actually run simultaneously? Targeting separate risk profiles, different cost-saving goals, or unique customer segments, all without writing a single new line of code. Welcome back to the deep dive. Today we're getting into something that's kind of like the genius of invisibility. We're talking about how custom apps inside the Shopify admin can feel so completely native, so seamless.
Right.
We're going to crack open the architecture behind it, focusing on the two main pillars, App Bridge and the Polaris design system.
The big two.
Exactly. Our mission here is to really understand the thinking behind it. You know, what makes an external app, maybe one hosted on Vercel, just disappear into the Shopify ecosystem?
Well, to really get the solution, you have to start with the problem. And almost every modern Shopify app is what's called an embedded application.
Okay, embedded.
It means it's hosted somewhere else, but it's displayed inside an iframe right there in the Shopify admin.
And an iframe is basically a box, right? A security sandbox.
That's the key. It's a sandbox. It isolates the app from Shopify's core code, which is great for security, but it creates this huge barrier. So the entire effort is about creating the illusion that you never left Shopify.
Okay, so let's unpack that illusion. Let's start with the look and feel. If the iframe is the sandbox, then Polaris must be the official playground equipment inside it.
That is a perfect analogy. Yeah. Polaris is Shopify's open source design system. It's a React component library.
And you pretty much have to use it.
You do. If you try to use, just standard HTML or your own CSS, your app immediately looks out of place, jarring. And most importantly, it looks untrusted.
So it's a trust signal.
A huge one. Using Polaris components like page, layout, or a card, it's the fastest way to look legitimate.
It's the visual handshake. I see a standard text field or a resource list, and my brain just says, okay, this is safe, this is Shopify, I don't have to learn a new UI.
Exactly. And Shopify mandates this. It protects their brand. Every app reflects on the entire platform.
Okay, so aesthetics are one half of the battle, but what about the logic? My app is in this secure box. How does it talk to the Shopify admin around it?
That is the million-dollar question. And the answer is App Bridge.
App Bridge.
It's the JavaScript library Shopify provides. Think of it like a secure official telephone line that connects your app across that iframe barrier. Without it, your app is just an island.
And this is where it gets really powerful, right? Because it's not just about data. App Bridge lets the app control the native Shopify UI.
Yes, you start controlling things outside your iframe. For instance, your app can tell the Shopify admin to show the main save bar at the top of the page.
Oh, what?
Or display a toast notification. Those little success or error pop-ups. They appear in the main admin, not inside your app's little window.
And I think the most powerful example of this has to be the resource pickers.
Absolutely. This is a game changer for developers. Instead of building your own, maybe insecure interface for searching products,
You just ask Shopify to do it for you.
you just ask Shopify. You use App Bridge to say, hey, open your native product picker. You set the resource type to product, and Shopify handles everything, the UI, the search, the security.
That's huge. It saves so much time and keeps everything secure and consistent.
It's mandatory centralization.
So for a developer just getting started, they're not putting this all together from scratch, are they? They'd use the command line tools.
Right. You'd run npm init at Shopify at latest. That spins up a Remix app template for you.
And that template has all of this baked in.
It does. It sets up the App Bridge connection in a main layout file and gives you the starter Polaris components. It's a whole toolkit designed to get you compliant from day one.
So to bring it all home, the seamless experience merchants get is built on these two layers that Shopify controls. Polaris for the look and the trust.
And App Bridge for the logic and the communication.
It's a complete system, one for presentation, one for communication.
And that actually brings up a really interesting thought for you, the person listening. If Shopify controls presentation with Polaris and communication with App Bridge, what other critical web functions, think about things like payment processing or, say, user authentication, do you think are also handled by specific mandatory Shopify tools to keep the whole platform secure and unified?
That's a great question to think on. That wraps our deep dive for today. Thanks for joining us.
Welcome to the Deep Dive.
Hey there.
Today, we're jumping into the architecture of the Remix framework, specifically with Node.js. Our whole mission here is to give you a shortcut, really, to get to the core of why this tool is so powerful for custom apps.
And it all starts with this foundational idea, this one file, two worlds approach.
Right. Instead of having your client-side code over here and your server logic way over there, Remix puts them together in a single route file.
Which is fascinating because that directly attacks the the biggest headache in web dev, right?
State synchronization.
Exactly. Keeping the server, the client, and what the user sees all aligned. Remix kind of forces the solution by defining where everything runs.
Okay, so let's break that down. In any route file, you've got 3 key exports. The first one is the default export. That's your React component. It's what you'd expect. It runs purely in the browser, and it renders the UI.
Simple enough. But the real power, it comes from the other 2, the ones that run only on the server.
So you have the export loader,
which is your data fetching function. It handles all your GT requests, and it runs before your component even loads.
And then the second server-side one is the export action.
Yep. If you need to change data think post, putty, delete a form submission, triggers the action, and it all happens securely on the server.
Which immediately brings up the question of security.
Of course.
You can't just be phishing private data by, hard-coding API keys on the server. That sounds like a disaster.
It's a huge vulnerability, and that's where Remix is really elegant. The solution is this little helper function, usually called authenticate.admin.
And what does that do?
It does 2 jobs at once, basically. When a request comes in, it first validates the user's session token.
Okay.
And then with that valid session, it instantly creates a secure, pre-authenticated GraphQL client.
Oh, so your loader function doesn't have to worry about any of that.
Not at all. It just gets handed this ready-to-use client, often just called admin, and you can immediately run admin.graphql to query your API.
Like in the examples where it fetches the first 5 orders, grabs their names and amounts, and then just sends that back down as JSON.
Exactly. It's a critical workflow advantage. The data is securely fetched on the server first.
Which means the client-side component, your default export, connects back to that data with a special hook, use loader data.
And the data is just there. It's available the moment the component renders.
So you avoid all those annoying data waterfalls and loading spinners you see everywhere else.
Precisely. Now that's fetching data. What about changing it?
The action function.
Right. When you submit a form to, say, update a product tag, that request targets your server-side action.
And I'm guessing it uses that same security setup.
The exact same. The action gets the form data, the product ID, the new tag, whatever, and uses that same authenticated client to run a GraphQL mutation, like tags add. Super clean.
Okay, and this is where that remix magic thing comes in, the part that's a huge efficiency gain.
This is the moment, yeah. So once that server-side action completes successfully...
Let's say it updates a stock count.
Perfect example. As soon as that's done, Remix automatically knows the data for this page has changed.
So it just reruns the loader function for you, automatically.
It does in the background. The server securely refetches the new state, the updated stock count, and feeds it right back to the client.
And the UI just updates instantly.
Instantly. And you, the developer, you didn't have to write any state management code to make that happen. No use state, no use effect for refetching. It's automatic.
That full stack synchronization is the whole value proposition right there.
It really is. So we've focused on flows that the user starts, clicking a link or submitting a form, but that leaves you with an important question to think about for your own apps. If the user isn't doing anything, what mechanisms do you need to handle changes that happen somewhere else, like an inventory update from an external system?
So things that happen asynchronously.
Right. It gets you thinking about how you would integrate things like webhooks and event subscriptions into this really elegant architecture. A great place to explore next.
Okay, let's get into it. Today we're doing a deep dive into webhooks and event subscriptions.
Right.
This is really the core mechanism for any kind of efficient, real-time, custom app. Our mission today is to sort of unpack why the old way of doing things is dead.
And what new traps, this faster, smarter way introduces.
Yeah, exactly. So let's start with that old way. Polling.
Polling, yes. It's the classic poll paradigm, and it's so wasteful.
Pull, because you're constantly polling the server for information.
Exactly. I mean, imagine your app is running a little timer cron job every 5 minutes.
And it's just asking the API, are there any new orders yet? How about now?
Over and over. And most of the time, the answer is no.
And the drawbacks for you, the developer, are just immediate. You get delayed data, you're using resources inefficiently, and of course, you're just slamming into your API rate limits.
For absolutely zero gain.
So webhooks, they flip the script entirely.
Completely. It becomes a push paradigm. The platform, let's say a commerce backend, it doesn't wait for you to ask.
It just tells you.
It hits your dedicated endpoint, your webhooks route. The millisecond an event actually happens, an order is created, bam, you get the data.
No delay. And importantly, no API cost for that interaction.
Right. Now, architecturally, how you set this up is key.
In modern dev, You're not manually setting these up anymore. You define them declaratively.
In the config file, yeah. You just list the topics you care about, like orders create or products update.
Which guarantees they're registered automatically when you deploy. Super clean.
And all that traffic from all those different topics, it all funnels to one single route handler. It's just a POST request.
And this is where it gets serious. This is the moment where security is, well, it's not optional.
It is absolutely non-negotiable.
So what is the single most critical step that handler has to take?
It has to validate the HMAC signature.
Okay, let's break that down. HMAC.
Hash-based message authentication code. It's basically a cryptographic signature that's included in the request headers.
And it proves the request is legitimate, that it actually came from the platform and not from
a hacker, a bad actor. If you skip this check, someone could just send you a fake order paid event.
And if your app is set to automatically fulfill paid orders?
You're shipping free products you've just been had. That signature check is the one thing stopping them. You have to use the validation helper. No excuses.
Okay, so once it's validated, the request is safe. Then your handler just routes the data.
Yeah. Based on the topic, orders create goes one way, products update goes another. And, you also need to handle the administrative stuff.
Like if you installed.
Right. That's your chance to do cleanup. Delete the shop's data, remove their session from your database, keep things tidy.
Now, here's a rule that trips people up.
Yeah.
No matter what happens, success, failure, an error in your code, what do you have to send back to the platform?
A 200 OK response. Always, without fail.
Even if your code breaks.
Especially then. Because if your app errors out or times out or sends back anything other than a 200 OK, the platform assumes the delivery failed.
And it will try again.
It will try again, up to 19 times over the next 48 hours. You have to signal that you received it, even if you couldn't process it.
Okay, that makes sense. But that leads to the next problem. The platform guarantees at least one delivery.
Which means sometimes you get two or more.
The exact same webhook payload delivered twice. And that's the idempotency problem.
Idempotency. It's a fancy word, but the concept is simple. Doing the same thing multiple times shouldn't have a different result.
So if your app's logic is to send a confirmation email,
and you get that order event twice, the customer gets two identical emails, that's a terrible experience.
so why don't they just guarantee exactly one delivery?
Because networks are messy, they prioritize making sure you get the data over getting it to you a perfect number of times. So the fix has to be on your end.
How do you do that?
Before you process anything, you check your database. You look for that event's unique ID, the Shopify, for instance.
And if it's already there?
You just skip it. You've already processed it. You just return that 200 OK and move on.
Let's make this concrete, the whale alert scenario.
I love this one. Okay, so you subscribe to Orders Create. A new order comes in.
The webhook hits your server instantly. Your code parses the payload, checks the total price, and if it's over, say, $500.
Bam. It logs whale detected. Well, that's real-time action right there.
And you can test all of this without a single real order.
Yep, just use the local dev kit, Shopify app, webhook trigger. You can simulate any topic you want. It's incredibly useful.
So the core takeaway here for you listening is pretty clear. Webhooks are the foundation for real-time efficiency.
But that power comes with responsibilities. Mandatory security through HMAC validation and robust reliability through idempotency checks.
We saw how declarative config makes deployment so easy. But that leaves a final thought for you to chew on.
Right. What happens, what kind of complexities come up when you need to handle webhooks from multiple different API versions at the same time? How does that change your fundamental approach to routing all this traffic?
Yeah, something to think about.
We are diving into a really fundamental pivot in application development. It's how do you handle a task that takes 5 minutes when your web server only has like 5 milliseconds?
Exactly. And our mission today is to really get to grips with the fire and forget design pattern.
Okay, fire and forget.
Yeah, it's absolutely critical when you're responding to time-sensitive things, especially webhooks coming from services like Shopify or Stripe.
Right. So the moment that webhook hits your server, the clock is ticking. You have to acknowledge it immediately. What happens if you don't?
The external service just assumes failure. They are operating on a super rigid time limit, maybe 5 to 10 seconds.
That's not a lot of time.
Not at all. And if you try to process a complex order or generate a PDF in that window, it just times out. It assumes the transaction failed.
And then it probably retries, causing more problems.
Precisely. So the core rule is this. Verify the signature, add the job to a queue, and immediately return that beautiful, quick 200 OK.
So if we accept that rule that the webhook handler has to be just a producer, basically, what's the industry standard tech for managing that queue, say, in the Node.js and Remix world?
Well, reliability is just paramount here. So the standard stack is BoolMQ backed by a Redis database.
Okay.
The architecture is actually pretty straightforward. Your webhook handler, that's the producer, adds the job, let's say sync order, to the Redis list. That whole thing takes 5 milliseconds, and you're done.
Hold on, though. Isn't spinning up Redis just for background tasks kind of overkill for smaller applications, or is it really the only way to guarantee that reliability?
It guarantees reliability, persistence, and scale. And you need that reliability for the second piece of the puzzle, the consumer, the worker.
Which is a totally separate process.
A completely separate process. It's a background script running outside your web server. It just watches that queue and does the heavy lifting.
So that's the thing that can take 5 minutes.
It can take 5 minutes. It can take a coffee break, whatever. It can generate invoice PDF or sync data to an ERP system. The original service doesn't care one bit. They got their 200 OK ages ago.
That makes perfect sense for event-triggered tasks. But applications also need recurring scheduled tasks, things with no external event, just a specific time like sync inventory every night at 3 a.m.
Right. Now we're talking about traditional cron jobs. For apps on, let's say, an always-on server, developers often just reach for the Node cron library. You give it a standard cron schedule format like 03 for 3.0 a.m. daily, and it just runs your function like sync inventory for shop. Simple.
But this is the crucial warning, right? The aha moment. If you're hosting on a serverless platform like Vercel, Node cron is a non-starter. It just will not work.
It absolutely will not work.
Why is that?
Because serverless scales to 0. If no one is hitting your site, the code isn't running. There's nothing there to execute the schedule at 3 a.m.
So that forces a pretty big architectural choice.
It's a huge strategic decision. If you go serverless, you must rely on an external scheduler, something like Vercel cron, which hits an API endpoint for you, or a dedicated service like Mergent or EasyCron.
So wrapping this up, what does this all mean for the architecture you choose?
It means there's a really clean duality here. You use BoolMQ and Redis for those slow event-triggered tasks that need that instant 200 OK.
And for everything else.
And you use Node cron, or an external service if you're serverless, for all of your time-scheduled recurring jobs.
So the next time you deploy, here's something to think about. How radically different does your strategy need to be just to run a simple report every single minute? Depending on whether you choose a traditional server versus a serverless one, your entire background processing architecture is dictated by that one choice. Welcome to the Deep Dive. Today, we're going to be focusing on business-to-business, or B2B, inside the Shopify Plus world. And this isn't just, a feature they bolted on. It feels like a fundamental architectural shift.
Oh, it absolutely is.
So our mission today is really to unpack how the platform has to completely reorganize its data model to go from that standard, direct-to-consumer retail to handling these massive wholesale relationships.
And that's the key thing for you to grasp. If you're coming from a purely DTC world, the biggest mental hurdle is that the individual customer ID, it's just not the top of the pyramid anymore.
It's not the main thing.
Not at all. That whole structure just flips the second you turn on B2B.
Okay, so that's a huge shift. If the customer isn't the primary organizing principle, then what is? What's this new hierarchy we need to understand?
Well, you basically move up a level. So at the very top, you have the company.
Like Acme Corp, the legal entity.
Exactly. Then, one level down, you have the company location. Think of these as the actual shipping destinations. So Acme HQ NY, or maybe Acme Warehouse PX.
And only then at the very bottom do you get to the person.
Right. The contact. That's your human buyer, your John Doe.
So John Doe is at the bottom of the pyramid.
And what's really fascinating about the architecture is just how flexible it is. A single contact, so John Doe's user account, can be assigned to multiple companies.
Oh, interesting.
So he can buy for Acme on Monday, and then on Tuesday he's buying for, Globex. And the system just handles that identity swap perfectly.
That makes a lot of sense. The platform has to know not just who you are, but who you're shopping for.
Yes.
And it personalizes the whole storefront based on a simple check, like if customer that B2B or something like that.
Precisely. But the real engine behind all this, the cornerstone of the whole operation, is what they call the catalog.
Right. The catalog.
Because a B2B buyer should really never see the retail price. They only ever see their price, their negotiated price, from their assigned catalog.
So how does one system manage all that? It sounds way more complex than just a simple price list.
It is, yeah. A catalog is really a combination of three different things. First, you have the price list.
Okay.
That can be, a simple percentage off retail, or it can be completely fixed, custom prices for every single item.
So total control. What's the second part?
The second is the publication. This controls which products are even visible, so you can completely hide parts of your store from certain companies.
And the third?
And third, you have quantity rules. So this is where you enforce things like minimum order quantities or MOQs or even purchase increments.
Let's use that Dunder Mifflin example. So if a ream of paper is $100 retail, but the Dunder Mifflin catalog gives them, say, a 40% discount,
then their buyer only ever sees $60.
they never even know the $100 price exists.
And they shouldn't. That's key for protecting your margins. And those quantity rules are, they're non-negotiable for wholesale.
Right. So if Dunder Mifflin has to buy in cases of 10.
The system makes them. If a buyer tries to put 1 in the cart, it'll just autocorrect to 10. It enforces that business logic right there.
Which brings us to the checkout. I mean, the whole B2B checkout experience is it's fundamentally different from what a DTC shopper would see.
Completely different. You're not just hitting pay now. There are, I'd say, 3 major distinctions in that flow.
Okay, what are they?
First is payment terms. Many of these orders start out as a draft order.
And then it becomes an invoice later, like net 30.
Exactly, net 30, net 60, whatever you've negotiated. Second, the checkout automatically adds a field for a purchase order number, a PO number.
Which is essential for their accounting department.
Absolutely mandatory. And the third thing is vaulted cards.
Wait, a vaulted card? Isn't that just a saved credit card? I have that on Amazon. Why is that a B2B thing?
That's a great question. The difference is who it's saved to. In B2B, the vaulted card isn't tied to John Doe, the person. It's tied to the company location account.
Ah, so anyone at Acme HQ with permission can use the corporate card on file.
Exactly. It makes reordering for a large team so much faster, which is, vital for high-volume accounts.
So to sum it up for you, the listener, the whole architecture pivots. You move away from the individual shopper to this multi-layered company hierarchy.
Yeah.
And that whole experience is then driven by this really powerful customized catalog system. It's an identity flip, first and foremost.
It is, and that leads to a final thought, this idea of identity context. It goes really deep. Let's say you're building a headless B2B site, something outside of the normal Shopify storefront.
Okay.
The single most critical piece of data you have to pass when you create a cart is that company location at.
Without that context.
Without that context, the system has no idea. It doesn't know whose prices to show, whose rules to apply, and your cart just won't work. That location context is, it's everything.
Welcome to the deep dive. Today we're really zeroing in on Shopify Plus and one tool in particular, Shopify Flow.
Mm-hmm.
Our mission is to understand how this, no-code tool can actually become the brains behind some seriously custom back-end operations.
Exactly. And at its core, Flow is just programming logic, but in a visual builder.
Yeah.
Every single automation, no matter how complex, it always starts with the same 3 things.
Right, the foundation.
The foundation. You get your
Okay.
trigger, that's what kicks things off.
Yeah.
Then the condition, which is your I-thin logic. And finally, the action, the job you actually want to get done.
That foundation is simple enough, but the thing that changed the game was when Flow could look beyond the data in that initial trigger.
Oh, absolutely. That old limitation is completely gone now. We have the get data action.
And what does that let you do exactly?
Well, think about it. For a big enterprise, speed is everything. A flow might trigger on order created. But that trigger only has basic order info. With get customer data, you can pause mid-flow and pull in related stuff, like that customer's total lifetime spend.
I see. So you can make a smarter decision about this new order based on their history.
Precisely. It gives the automation intelligence.
So if get data is the intelligence, what gives Flow the reach? The ability to talk to systems outside of Shopify?
Okay, that would be the send HTTP request action. And honestly, this is a total game changer for enterprise clients. It's like true serverless integration.
Serverless how? You mean you don't have to build and maintain a whole separate app just to send an alert somewhere?
You've got it. You just define the method, like a postie, the URL you want to send it to. And then, this is the magic part, you structure the JSON body right there in Flow.
And you can use variables in that JSON.
Yes, exactly. You can pull in dynamic variables like order.name or the order.totalpriceset.shopmoney.amount.
How does that actually save maintenance time, though?
Because it's all visible. The API endpoint, the variables. A merchant team can go in and tweak the alert text or change the endpoint without ever talking to a developer. No code deployment.
Okay, let's pivot. Let's make this real. High stakes scenario. Fraud management. You need to catch it instantly.
This is a perfect example, but the timing is critical. You can't use order created.
Why not?
Because the risk analysis happens a split second after the order is placed. So you have to use the order risk analysis analyze trigger.
Got it. So the flow only runs if the risk level is HAH and the recommendation is cancel.
Right. And then you fire off 2 actions at once.
A dual action.
Correct. Action 1 is internal, something like add order tags with, say, a red circle emoji in fraud review.
And action 2.
That's external.
Yeah.
You use that HTTP request to immediately ping a Trello board or a webhook.site, pushing the order name and risk level to the finance team, right where they work.
That is just immense operational efficiency. What about B2B?
Oh, B2B is another huge one. Think about onboarding new companies.
A lot of manual checks there.
Usually. But with Flow, you trigger on company created. If their company location country code is, say, US, you can just have an action that automatically sets their status to approved and assigns them the standard catalog.
So what was a 4-hour manual process is now?
0 seconds.
It's incredible. And finally, let's touch on this idea of Flow as a function activator. This is where a visual tool starts controlling actual custom code, right?
It's a fascinating concept. You can use Flow's scheduler to control back-end customizations. Imagine you have a custom payment option, like net30 terms, that's controlled by a metafield-shop.custom.hidenet30.
Okay.
You can schedule a flow that just says, if time is weekend, then update that metafield to true.
And that hides the net30 payment option on your checkout, all from a scheduled visual flow.
Exactly.
So if we pull this all together for our listeners, Flow lets you automate these really complex external integrations like that fraud system, but also orchestrate your own custom backend logic like hiding payment terms, all from one visual no-code builder.
It really does. And if we want to connect this to a bigger picture, think about this for a moment. Scheduling metafield updates means your visual automation can control the most specialized parts of your storefront and your backend at the same time. So what does that open up for you? What kind of regional compliance rules or even tiered feature access could you automate if you had that level of granular scheduled control?
All right, let's get into it. Today we're doing a deep dive on what it really takes for a huge e-commerce site to survive its biggest moments.
We're talking about massive scale, like 50,000 users hitting your site every single minute.
Exactly. So our mission here is to give you the shortcut, the inside track on how these enterprise platforms manage that kind of scale and maintain perfect timing.
It's a real tightrope walk, architecturally speaking. You're balancing absolute precision with just total resilience.
And that precision part is key. For a huge launch, like a Black Friday theme going live, you can't just have someone click a deploy button at midnight.
No, absolutely not. There's way too much risk. That's where a platform feature like Launchpad is so critical.
So Launchpad is basically a scheduler.
It's a scheduler, but it's more than that. You build your new theme, you get it perfect, and then you tell Launchpad at 000000000 ET, swap the live theme. And the real magic here is that it's an atomic change.
Atomic, meaning it's all or nothing, instant.
All or nothing. The entire switch happens right at the core platform level. So you get, zero downtime, perfect timing every time.
Okay, so we've nailed the perfect launch. But that beautiful new theme is immediately met with that tidal wave of 50,000 users.
Right. And all that perfect timing means nothing if the site immediately crashes.
So what's the guiding principle? What's the one rule for surviving that spike?
The rule, and it's basically the only rule that matters, is avoid hitting the database.
Serve everything from a faster layer from cache.
Everything. For a classic liquid theme, that means you're using the cache. True tag on every single reusable section. Your header, your footer.
All the static stuff.
Exactly. It cuts down your render time like you wouldn't believe. But if you're headless with something like Hydrogen, you have to go even further.
And that's where aggressive edge caching comes in.
Right. You might set your smaxage to something like an hour for product pages.
Okay, but hold on. An hour. In the middle of a massive sale, inventory is changing by the second. Don't you risk selling things that are already gone?
That's the million-dollar question. And the answer is webhook invalidation. The cache is smart. It only gets purged if the inventory for that product actually changes.
So you get that to both worlds. Speed, but also decent accuracy.
You're minimizing requests while keeping the data just current enough. Now, this brings us to webhooks, which are critical for custom apps.
And this is where things get really, really sensitive to time.
They have to be lightning fast. Your webhook handler must, and I mean must, take less than 50 milliseconds to respond.
50. That's not a lot of time.
It's nothing. If
Yeah.
you have a task that's going to take longer, like a big inventory update, you can't do it synchronously. You have to push it to a queue immediately.
Because if you don't, that thread hangs and the whole system starts to buckle.
The whole thing crashes. And the same logic applies to the checkout itself. The modern approach is to move away from custom liquid scripts.
And move towards functions.
Yeah, because functions run on Shopify's core logic. They scale in a way that old custom checkouts just can't.
Okay, so your site is solid, but your apps are still hitting external APIs, and those have limits. Let's talk about the admin API's leaky bucket model.
Right. Just picture a bucket with a slow leak. Every API call you make takes some water out. The API slowly drips water back in. If you take too much, too fast.
You run out. You get that 429 too many requests error.
And the worst thing you can do when you get that error is just try again immediately.
They're just hammering an empty bucket.
Exactly. The only strategy is exponential backoff. You wait. If you fail, you wait 2 seconds. Fail again, you wait 4, then 8, then 16.
And you're giving the bucket time to refill. It feels counterintuitive to slow down during a rush, but it's the only way to let the system heal itself.
It's the difference between self-healing and total collapse.
That level of detail is just, it's everything. And before we wrap, here's a little micro-optimization I love. For liquid, try to use liquid percent unless product.available%.
Instead of percent if not product.available.
Yeah, it's cleaner, a bit more readable, and it's just marginally faster. It all adds up.
And that's really the point, isn't it? When you start mastering all these things together, Launchpad for precision, aggressive caching for speed, exponential backoff for resilience, that's when you make the jump.
You stop being just a developer.
You become a true enterprise solutions architect. You're thinking about the whole system.
That is the knowledge shortcut delivered. So, a final thought to leave you with.
If the key to scaling e-commerce is avoiding the database, what's the resource bottleneck in your own work? What tasks or even meetings could you solve by aggressively pre-caching information or decoupling dependencies? Think about where your own internal systems get stuck.